How do we write object-oriented code in ES6? JavaScript has a prototype-based object-oriented programming model. It creates objects using other objects as blueprints. And to implement inheritance, it manipulates what's called a prototype chain. We normally call the way object orientation is implemented in other languages like C++ or Java as the classical OO pattern, and the way it's implemented in JavaScript as the prototype pattern. Although the prototype pattern is a valid way to implement object orientation, it can be confusing for newer JavaScript developers or developers used to the classical pattern. So in ES6 we have an alternative syntax, one that closer matches the classical object-oriented pattern as is seen in other languages. But under the hood, this new syntax still uses the prototype pattern with constructor functions and the prototype chain. However, it provides a more common and convenient syntax with less boilerplate code. Now, as a quick note, TypeScript supports the ES6 class syntax, but also adds other features like access modifiers and interfaces. So in this section, we'll be writing TypeScript rather than pure ES6. And we'll also be coding locally instead of via Plunker. So we can use our TSC tool to transpile our TypeScript into JavaScript. And we'll be using Node to execute our transpiled JavaScript file. A class is a blueprint for creating objects with specific functions and properties already attached to it. Let's go through a simple example. We define a class using the class keyword. We then describe the properties which we eventually want on the instance that we create from the class. I'm describing two properties, one called first name and one called last name. And when they're created, they'll be initialized to the empty string. Each class has a special constructor function. This is called when we create an instance of a class with new. Inside the constructor function is where we put our code that we want executed when the object gets created from the class. We then describe some functions, also known as methods, that we eventually want on our class instance. So I'm going to create a function called name. So I've created a function called name, and what name does is it just returns the first name and last name together as a string. And inside our name function, I'm using a special variable called this. Now this doesn't point to the class. The class is just a concept. It's just a blueprint. This points to the object that we've created using the class as a blueprint. And I'm also going to add another function called whoareyou, which I'll just copy and paste in. And from methods in our class, we can also, in fact, call other methods in our class. So I'm calling the name function from the whoareyou function. So as I said, a class is a blueprint for creating an object. We call that created object an instance of a class, or a class instance, or just instance for short. We say we instantiate a class by using the new keyword. And when that happens, JavaScript calls the constructor function. We can then pass to the constructor arguments, which it uses to initialize properties or call other functions, like so. So I can create an instance called Asim, new. So this creates an instance of the person class called Asim. So the Asim instance has a first name and last name property, and it also has a name function and a whoareyou function, which I can show you by logging the whoareyou function. So in the bottom part of my editor is in fact a terminal, and I'm going to use the TSC command to compile my class to a JavaScript file. So you can see here, it's been compiled. Now, an important thing to note, so we have compiled this class into ES5, and ES5 doesn't support the class keyword. So what it's done is it's tried to create a class using the kind of mechanisms that we would use in ES5 world to define classes. If we in fact use tsc -t ES6 to compile class, and then we look at the JavaScript file, we can see that the JavaScript file actually looks very, very similar to our TypeScript file. Because so far, we actually haven't started using any features that's just TypeScript. Everything we've written so far is actually just ES6 JavaScript. So a class can inherit from another class. We can create a class blueprint that extends an existing class blueprint by adding other methods or properties. So we do this by using the extends keyword. So I'm going to create another class called student, which extends the person class. So now this student class, this blueprint, has the first name and last name property and has the name and who are you function as well. So I want to add another property called course, which is going to be blank to begin with. I then add another constructor, take the same arguments, but we'll additionally pass in a course argument. Now what we want to do here is we actually want to call the constructor of the base person class. I want to call this constructor and I want to pass in first name and last name. Now we can do that by using the special super keyword. I can pass in first name and last name. This then calls the base class, the constructor of the person class, and the constructor of the person class sets the first name and last name. But additionally, I want to initialize the value of the student course property as well, so we can do that here also. And also, I'm going to change the who are you function. So the student blueprint will also has the who are you function blueprint, but I need a different blueprint. I need a different who are you function, one that also returns the course. So what I can do is I can override the who are you function from the person class just by defining it again. Who are you? And I'm going to have it return something a little bit different. So there's no point printing out, hi, I'm this name, and I'm studying the course. So we could write it out like this, but we don't need to. I mean, I've already got hi, I'm first name, hi, I'm name being returned by the base class person function. So wouldn't it be great if we could just replace this by a call to the original who are you function? And we can do that again just by using the super keyword again. So I can call super who are you. So this then calls, despite the fact that we're in a function called who are you, this then calls the same function who are you on the base class, on the base person class. So it returns, hi, I'm Asim Hussain, and I'm studying, and whatever the name of course that we give it. So now if I want to create an instance of student, I can just say new student, and I pass in the course, and I'm studying Angular 2. So now I can again print out, compile class.ts into a JavaScript file, and then I'll run it, class.js. And now it says, hi, I'm Asim Hussain and I'm studying Angular 2. So that's how we implement inheritance with this new class syntax. Everything we have learned so far about classes is pure ES6 JavaScript. However, TypeScript adds some nice functionality on top of ES6 classes, namely function and property visibility via access modifiers. For example, we can define the properties of our person class as private. And then if we created an instance of asim from person, and then if we add a function onto our student class, let's just call it test, where we just log the first name. And then let's try and call this test function. Let's see what happens now when we compile this using TSC. We get the error property first name is private and only accessible within class person. By making first name private, it's now only visible from one of the functions in person class. The first name property is no longer visible from a function on the student class. We can also define a function as private, and it has the same effect. Now the whoareyou function can only be called from another function within the person class. And since we're calling it from the whoareyou function in our student class, this should return an error. Well, it should return 2 errors. Let's have a look. Actually, it's returning 3 errors. The first error is that the student incorrectly extends base class person. So because we've marked the function private in the base class of person, it has to be private as well in the extended class. But as well as that, because we've marked whoareyou as private in the base class, our call to whoareyou by using super in our student class, this will fail as well because we're now not allowed to call the whoareyou function from outside of the person class. And that last error is just our old error with the test function. So there are 3 different types of access modifiers in TypeScript. There's public, and this is the default, and it means it's visible everywhere. So if we mark it as public, then our code will work, but also not providing anything default to public anyway. So really what we've been using so far has just been public. There's private, which we've gone through already, which means that only member functions of the class it's declared in can see whatever it is, be it a function or a property. And there's a third one called protected. And protected means that only the class it's declared in and any class that inherits from that class can see this. So because we're extending student from person, this now means that calling test, this should work perfectly fine. And because student extends person, it has access to the protected members and functions of person. A really common pattern in constructors is to use them to initialize properties via arguments you pass into the constructor, like in our example. So we're passing into the constructor first name and last name, and then we're setting those as properties on our class instance via this.firstName. Properties with the same name as the argument that we're passing into the constructor. But if we pass in these arguments with an access modifier, let's say public, TypeScript then lets us shorten this to just this. It will automatically create properties on our class with the same name, and it will initialize them with whatever values we're passing into the constructor. So now if I compile this, and let's compile it to ES6 so you can see what's going on, and I open up the JavaScript file, you can see what it's doing. It's initializing a first name property with the first name that's being passed in, and a last name property with the last name that's getting passed in. So just a neat little shortcut you can use, and it only works with TypeScript. TypeScript has another feature called an interface. An interface can be used in a number of scenarios, but by far the most common is when used with classes. So when used with classes, the syntax looks a little bit like this. I'm going to use it on the person class. So I'm going to say class person. So I'm going to say class person implements human. Human in this example is an interface. And an interface lets you describe the minimum set of public-facing properties or methods that a class has. Another way interfaces are explained is that they describe a set of rules the class has to follow, a contract it has to adhere to. So for us, a human interface might look something like this. Just an important note, since interfaces are all about the public interface of a class, they can't have access modifiers. Any properties or functions you declare on them are all public. So now that we're saying that person implements human, if person class then doesn't implement a first name or a last name, TypeScript will throw an error. So let's actually, to demonstrate this, let's call it first name 2. So now if I compile this, now it's saying class person incorrectly implements the interface human. Property first name 2 is missing in type person. So the person class doesn't adhere to the contract, to the agreement for what a human interface would look like. Sometimes, however, we might want an interface to describe an optional contract. So to do this, we can append the question mark to the name of the property or function to mark it as optional, like so. So we can say name, question mark, and the type of name is function, or even is late. And that's another function. So now name is declared on the person class, so that's fine. Is late isn't declared on the person class, but that's fine, it's optional. So that should compile fine. So in summary, in ES6 we now have a new way of writing object-oriented code with the class syntax. We can inherit methods and properties of one class into another by using the extends keyword. Under the hood, we are still using prototype-based inheritance, but the syntax is easier to understand and more familiar for developers who are coming from other languages. TypeScript adds some extra functionality on top of ES6 classes, such as access modifiers and interfaces. And in the next lecture, we're going to look at how we can implement our own decorators.